are you all doing? Hello everyone. Just a second. How are you all? Hi Sona. Tamil exam irukke. What does that mean? Ivange. Vedish, can I call you Vedish? How are you all? How are your exams going? First tell me that. Oh, Ramesh is here. You remember me? Okay, great. Hi. Joseph, I remember your name. Okay, Sona. Hi. All your exams, hi. How are your exams going? Lichi. Hi, Lichi. How are your exams going, everyone? Math exam, I heard, was a googly, isn't it? Is my voice, am I audible correctly or not, everyone? Let me know if my voice is breaking, as Joseph is saying. Nice, okay. How did your maths exam went? Oh, today was your English exam. How are you all doing? English was good. Okay, okay. Great. Great, great. Next exam is your science. How is the Josh? How is the feeling about the science exam after watching the math exam? Now tell me, how is the feeling? Ma'am, Tamil exam also there. How now science? Yeah, like we are basically covering the science here. You can start studying science as well, right? We just have 3 days. Hi, Gaur, Mas Gaur. We need justice for maths exam. Okay, okay, we'll fight. Afraid of science, Lichi is saying. Okay, hi, hello, Mas Gaur, how are you? Okay. Yes, yes, you will get justice. I think Lichi is saying English was good. So, isn't that a little bit of justice? There, I know. We all are scared, I know, especially after the maths exam. That was a tricky thing CBSE played. It's fine, it's fine. From our side, what we can do is, we can clear our basics, right? That is all you need, mostly. If your basics are clear, you can just build up to that unexpected question or the difficult question, right? See, even if you can't solve the question, you can at least write the steps, right? So when you write the steps, you'll get stepwise marking, correct? Although today, now we are going to study all about ray diagrams, right? Why? Because ray diagrams are very important for our science, whole science, right? Especially in physics, we know the highest weightage chapter is light, and from light most of the questions will be of ray diagrams. Of course, refraction, glass lab will also come, but majorly that will cover as well. On Monday I will be coming live again on 5 p.m. So what you have to do, till 5 p.m. you have to complete your self study. From 5 p.m. till the night we will do all the PYQs, sample question papers. Okay, this session will be at most will be till 6. Okay. Sorry, my throat is a bit itchy. Okay, give me a thumbs up. Can we start this live now? Can we start with our session? Hi Rishabh, hey yo. How are your exams going? 2 hours at most. Okay, so we will cover all the ray diagrams so that you don't have to go through it again till your science exam. Done? Okay, let's start this session. Give me a thumbs up if we can start this session now. Okay, we have lots of thumbs up. Nice, Rishabh is saying great, great. So proud of you all. Okay, let's start our very first topic in the ray diagrams. We can say, hi Ritik, how are you? Abhinav, Ritik, hello everyone. We are going to see all about ray diagrams today. Small day, we have a small day, so we'll try to cover everything about ray diagrams, and you have to cover all the small chapters, right? Our environment, chemical reactions, acid, bases and salts, all these chapters you complete today, right? I'm great, Ritik, I'm great. Okay, let's start with the very first. For the ray diagrams, we have 4 optical instruments is what we call them, right? We have 4 optical instruments: concave mirror, convex mirror, concave lens, convex lens. Now, in the live chat, there is a very fine rule of this live. You have to have your copy and pen. That's the only motive here, right? We are here to revise. So, I'll ask you some questions. I'll ask you kind of questions that the board will ask, right? So, for the very basic, for the very first, let me know which mirror and which lens are similar. Like concave mirror has 6 cases. Convex lens or concave lens, out of those 2, which have same cases? Yes, we will cover that. Case 7 will cover how to solve all the numericals of the chapter electricity, right? Okay, now let's start with the very first. Before that, I have a very amazing thing for you. There is a link in the description of this live session. You can go check that out. What is that link? That link contains a PDF. You have to get formula. So in that PDF, you will get all the important notes of biology, chemistry, as well as physics. Good afternoon, good afternoon. Okay. You will get all the formulas of physics in a cheat sheet. It's kind of a cheat sheet, right? I've been telling you to make a cheat sheet and paste it in front of your wall, but okay, let me give that. I made that formula sheet for you guys. There are all the important diagrams of biology, all the important chemistry reactions, as well as all the formulas of physics that you need. Right? For electricity, you will need formulas, right? So go check that PDF out. You just have to fill your mobile number and you can continue, and you can download that PDF for free, right? It's of no cost. Okay, Ramesh is saying, I think concave lens and concave mirror. Okay. Let us see the very first thing we are going to do today. The first optical instrument we are going to see is concave mirror, right? It will be concave mirror. Now, in concave mirror, how many cases are there? How many cases are there? Welcome, Ritik, welcome. I hope it is useful for you guys, right? We have, see, there are concave mirror and convex lens, ma'am. Very good. What should I call you? I don't know how to pronounce your name. Okay. I have a little bit of idea, Ramesh, but no. 6 cases, Abhinav is saying. Very good. Now, yes, you guys are correct. Concave mirror and convex lens are very similar, right? Both have 6 cases. The placement of object is very similar, and even the image formed is quite similar, right? Nature of image formed is similar, size of image formed is similar. So we'll see all about that. First, we are starting with the 6 cases of concave mirror. Correct? So concave mirror, my friend, we have object and image. There are 6 cases. Now we studied this technique very early, right? The technique is what? This is focus, this is center of curvature, right? The technique is 1, 2, 3, 4, 5, right? So infinity, that is 1, and then 2, 3, 4, 5, and 6, right? Where this is the position of object. This is the position of object. Okay? Now, where will the image be formed? Sorry for that. I'm so sorry for a little bit of coughing because my throat is not in a better condition. Okay, so for 1, 2, 3, 4, 5, 6, object at infinity, image at focus. Object beyond C, image between C and F, right? So you just have to write the counting in a reverse manner. Again 3, 4, 5. As we go around, we'll understand, we'll come back to this slide. Okay? Everyone understood? Okay, let's start with the very first case, that the object is at infinity. I'll make the diagram here. What you have to do, object is at infinity. Where the image will be formed, everyone tell me that. Everyone in the chat, let me know where the image is formed, where the image will be formed if the object is at infinity. No, I didn't, Ramesh. Okay, everyone, let me know where the image will be formed if the object is at focus, if the object is at infinity, sorry. Okay, we have the answer as focus. Great. Now, how you have to have your, what did I tell you guys? What did we say, kids? You have to have your pen and paper with you. Make these diagrams with you. This is your final revision. Correct? Focus of the mirror. Very good. Lacy layer was, I'm so sorry for this, whatever your name is. Okay, so from the infinity, all rays are coming parallel. All rays are coming parallel to what? Parallel to principal axis. All rays will be coming parallel to principal axis and they converge. Why? Because my concave mirror is a converging mirror. Great. My concave mirror is a converging mirror. So all the rays coming parallel from infinity will converge. Hi Anuj. Hi Ankit Sharma. Okay, so all the rays will converge at the focus of the mirror. What is the focus of the mirror? The focus of the concave mirror is on the same side. So all the rays all the reflected rays will pass from the focus. Done? Understood, everyone? Does this make sense? Do you remember all of this? Okay, great. Now let me know what is the nature of image formed in this case. What is the nature of image formed in this case? Radhe Radhe Ayushi. Hello Abdul. Hello Shanku. The nature of image formed in first case. Between F and C. For which case you are talking about? Nature. I asked nature. In nature we tell either it's real or inverted or it's virtual and erect. Hi Shanku. Highly diminished. Great. So you have to tell, when they ask you about the nature of image formed, you have to let them know about two things, right? You have to, which color should we use? You have to tell them about two cases, right? Image is formed at focus, right? Image is formed at focus, correct? Now, size of image, the image is very small, so the size of image is point sized, right? Size of image is point sized and the nature of image will be real and inverted. See, this time CBSE is in the mood of playing tricks on you, so you should know the basics. Why this is called a real and inverted image? Because real rays are getting reflected and are actually meeting at that point. Sorry. Okay? Ma'am, 12th physics बहुत hard. Yeah, I saw the paper actually. Most some of the questions were hard, but yeah, I'll give it that to you. 12th paper was hard. Okay. Done? Hi Sona, welcome back. Great. The real and inverted, why? Because inverted we'll see in other cases. Here it's just point sized, right? Now, why it was real? Because actual rays are converging. Okay, done? Okay, moving on to the second case, the object is beyond C. The object is beyond C. Where? Let me know in the live chat, everyone, quickly, where the image will be formed. And second, what is the nature of image formed? Yeah, hi Rudra. If you are class 10 students, we are here with you with the science practice, right? Okay. BMV is saying between F and C, real and inverted. Okay, let's see. Let's make the diagram, right? So the object is beyond C. Can I make this as the object? This is my object. Done. Now I have two options. I have two rays that will be coming from this object. First, the ray parallel to it, the ray parallel to principal axis, and then a ray. Now this ray, what will do? It will go back and pass from the focus. It will be passing from the focus. Done. Now the other ray will be passing from the focus. The other ray will be passing from the focus, right? From the focus, and then it will reflect back and it will meet another ray. It will meet another ray, this previous ray, at a point. What is that point? That will be, my friend, your new image formed. Done? Understood? See, you also have to use scale and pencil for this, right? Case 7 is saying, I need to write Tamil exam also. I'll ask you to start revising science now. Okay? We'll be coming live every day till 25th. So you come every day, you can revise it. Okay? And the rest of the time you can revise your Tamil language. Okay? Okay, great. Focus on study. Yes, Anuj Yadav. Great. So, what is the nature in this case? See, for all the cases of concave mirror, for 5 cases of concave mirror, the nature of image will remain same. That will be real and inverted. Real and inverted. Done? And in this case, see, you can clearly see the size of image is smaller. So, the image will be diminished. The size of the image will be diminished. Correct? Great. Ma'am, there is just one problem. What is the problem, Rudra? What is the problem? Yeah, I can understand you, BMV. You are in class 12th. I have done masters. So, see from my point of view. Yeah, physics was easy in 10th grade, but when you were in 10th grade, physics didn't look that easy. Numerical, Anuj, numerical will be from the chapter light, human eye and electricity. Human eye numericals can be tricky because you don't focus on those enough. Light numericals can be from hard to easy on CBSE mood. Same with electricity, but mostly from electricity and light. But this is also, human eye is also very important. Okay? You are from UP board, Rudra. It's fine. The syllabus the ray diagrams will be there in your syllabus, right? Okay, done. Let's move on. Yeah, this is diagram leak. Great. Done. 2 of the diagrams done and the image is formed between C and F. Which is the next case? Between C and F. What is the next case, everyone? What is the next case? Next case, my friend, is we have when object now is moved towards the mirror. The object is at C. The object is at center of curvature. Everyone in the live chat, let me know the image position as well as the nature of image. The image position as well as the nature of image. Now, the object is at C. The image will be, again, great, Abhinav, at the center of curvature. Great. Thank you, Rudra. Okay, done. See, again, my object is at center of curvature now, right? And 2 kinds of ray will come. Always the first ray from the object will come parallel to principal axis. They will ask you to make ray diagrams, and if you do any mistake, they will cut your marks. Done? So make sure you are watching this very carefully. So one ray is parallel to principal axis. It will pass from focus, right? It will pass from focus. Now this case is a little bit tricky because you have to mold the rays according to where you want the image. We know the image will be at C. Right? We know the image will be at C. So what I recommend you to make the image first. So this will be the image somewhat, right? This will be the image. We know this much. Now what you have to do, now make the other ray. Great. We are learning how to actually make the ray diagrams in this. we are learning. Now see, you have to adjust it according, right? So you can adjust the focus somewhere here so that your ray goes parallel. Okay, now this row, oops, now this ray goes parallel, and you have to make sure that it is cutting at this particular point. Correct? A little bit of tricks you have to use. Okay. Okay, my permission for what, Rudra? Okay, done. Great. Everyone, I know you are so excited to talk about the previous exams, but right now let's just focus on the new one, right? Set 1, set 2, they are in the past. Focus on the science one so that you don't come home and you are like, okay? No, Rudra. Okay. So size of the image at this point is same as object. Same as object. Done. And the nature, we know it's a concave mirror. It is simply real and inverted. Done. Any doubt? Exam is on 25th. Their exam is on 25th. कैसे मारूंगी ना FF gamer. Done. Let's move on to the next part. Next. Okay. Next case we have is the object is moving more closer to the mirror. That means the object is between C and F. That means the object is between C and F. Where will the image be formed? Everyone, where will the image be formed? So, we have again one ray will come parallel to principal axis, pass from focus. Let's just make the one we know. So, one ray will go parallel to principal axis and it will pass from focus. It will pass from focus. Done? Yes, beyond C. Okay, now next ray again it will pass from the focus. It will pass from the focus and it will come parallel to the principal axis, right? It will reflect back and go parallel to principal axis and it will go parallel to principal axis, something like this. And where these two rays are meeting, that is where my image will be formed. So image will be formed like this. Done? Done, everyone? Achha ji, BMV is saying I just study for 2 hours, then only I got 90 out of 100. Great, BMV. You are a superhuman. Okay. Now in this, image is formed beyond C. Great. The image is formed beyond C. Size of the image, we can clearly look. It is enlarged, right? The size is enlarged and the nature is for concave mirror, real and inverted. Right? Great. Okay, let's move on to the next part. We have case number 5th, that is object is now more closer to the mirror. So object is at focus. Achha, okay FF gamer, you guys are some real gems for the country. Okay. The object is at focus. Where will the image be formed? Okay, so all the 12th class students who are here just because they were bored, let me know where is your knowledge? Huh? At infinity, Abhinav is saying. Very good, Abhinav. Abhinav, there are two things. And you can say the image is at infinity, or you can, if there is written somewhere they have given that the image is not formed. That's also true because rays are not meeting, right? So image is not formed. Done. So again, the object is at focus, right? This is my object at focus. Now what I have to do? One ray will go parallel. One ray will go parallel and it will reflect back and pass from the focus, right? Correct. It will pass from the focus. Done. Next, what you have to do in this case, you can either do from pole and here, or you can go through center of curvature. What kind of space you have, you can follow that. So let's say the one ray is incident on the pole and it will reflect back with same angle, right? Angle of incidence will be equal to angle of reflection in this case, correct? Angle of incidence, angle of reflection. So see, both the reflected rays, they are going parallel. Then that means they are not meeting. So we say that the image is formed at infinity or it is not formed at all. Size will be highly enlarged, highly large, right? And the nature will be same, real and inverted. Now everyone in the chat, let me know the sixth case where the image will be formed, what will be the nature of image. No, FF gamer, if you do any spelling mistake in science, mostly they won't cut. But if you are writing diagram name, spelling of a diagram of, let's say, heart or some part of the heart, then they will cut the marks. Done. Behind the mirror. Very good, Abhinav Yadav. Very good, very good. Magnet chapter, Anuj, I will be coming live on Monday at 5 p.m. right? So we'll cover all the chapters, all the important questions, all the theory, everything of that chapter in a long stretched life. Done? Okay. Right now, because this is a small day, you have half of the day, so we are covering all the ray diagrams. Done? Okay. Now my object is between focus and pole. Correct? So one ray will go parallel and will then reflect and pass from the focus. That is constant. Done. Now the other ray, it is going something like this and it is coming back in the same manner, passing from center of curvature. Okay? Something like this. You have to adjust a little bit. Okay? It is coming something like this. Now this will go back, correct? This will go back because see, these rays are drifting apart. You can clearly see these rays are not meeting, they are drifting apart. So when the rays are drifting apart, we will stretch them backwards. And it appears to us that they are meeting behind the mirror. And hence this is our sixth case. Good morning, Ayushi, if you woke up just now. This is our sixth case and the image forms something like this. Now the image is formed behind the mirror. Now you can clearly see, right? The size is enlarged. And the nature. The nature in this case. What, Rudra? What you requested? Hi, Suryakant. Hi, how are you? Okay. So the nature is, in this case, it is virtual and erect. Done? Define me magnetic field. I have some doubts. Magnetic field is an area around a magnet in which the magnetic substance will experience a force due to the magnet. Done? Good morning, Ayushi. 1 minute, guys. Let me get my chai. My throat really needs some chai at this moment. Yes. Okay. Any doubt, anyone? We are done with all the cases of concave mirror. all of you went to English exam in sleep, huh? So that your mornings are happening at this time. Yes, Abhinav, we will clear all the diagrams, all the ray diagrams. Okay, and on Monday we will be doing numericals on these ray diagrams as well, and on all other topics. Okay, okay, let's move on to the next. Now concave mirror, let's make a quick summary of this. Concave mirror says it has 5 cases. First 5 cases, the image, nature of image is real and inverted, right? The nature of image will be real and inverted, and it is of all sizes, right? In the 6th case, the 6th case is, as we call, exception, right? So in 6th case, the nature of image will be virtual and erect. You understood how to actually make the diagram, and the size is enlarged. Ma'am, your sleep is also already going because you are giving the exam. How are you expecting to sleep? Yes, analog watches are allowed in centers. Hi Himanshi. Okay, great. Let's move on to next part where we will be covering convex mirror now. Now we only have 2 cases of convex mirror, right? Magnification I'll cover in Abhinav Yadav in just 2 slides. After these 2 cases I'll cover magnification also. Okay, just wait for 2 minutes. Now there are only 2 cases of convex mirror, right? First case, when the object is at infinity. So what will happen? All the rays are coming parallel, right? All the rays are coming parallel. Now let me know, is this a converging mirror or a diverging mirror? This convex mirror, is this a diverging mirror or a converging mirror? Your watch was analog or digital? Analog is the one with the kata. Diverging, very good. So instead of all the rays converging like this, it won't converge. The mirror is actually diverging, right? So what will happen? The rays will actually go back. They will reflect back something like this, right? They'll reflect back something like this, something like this. And when you expand them back, you will see that they are actually passing from the focus. They are actually coming from the focus, but the real rays are not meeting. The real rays are not meeting, right? That is why we don't say that the image is real and inverted. We say the image is virtual and erect, right? Because real rays are going back. They have no clue. They appear to be coming from focus. So virtual rays, they are virtual rays. That's why we call them a virtual image. Done? And the size is definitely point sized. And the image is at focus. Done? Everyone understood? Okay? Now, the second case, where will the image be formed? Tell me, where will the image be formed? Because this is a bit of a tricky case. You can say that the image will be virtual and erect, it will be behind the mirror. But where exactly will the image be formed? Kar do, FF gamer. Okay, so now the object is anywhere between infinity and pole. Let's say my object is somewhere here, right? Now one ray will again come parallel. It will come parallel, but this is a diverging mirror. ठीक है? So instead of going into the focus, it will reflect back, and now if I expand it back, it will look like it is coming from focus. Done. The another ray, however, the another ray now will pass from the center of curvature, and in the same manner it will come back, because we know the rays that passes from center of curvature reflects back to the same path. Okay, done. Okay, so this is where the actual image will be formed. This is image and this is my object. Done. Again, in this case, the nature of image. The nature of image is virtual and erect. The nature of image is virtual and erect, and the size of image is diminished. The size of image is diminished. Done. Images. Now be very careful. If they ask you the second case of convex mirror, where the image will be formed, it will be between pole and focus. Done. Anyone, any doubt? Anyone has any doubt in any of this? We are done with all the cases of concave mirror and convex mirror. Done. What is the weightage of diagrams? Very high, Abhinav. Almost all the questions you will be having from light. Only few of them, 1 or 2 will be from refractive index or refraction, right? Refraction also includes lenses, so only few questions will be from refractive index. The other, all of them will mostly be from ray diagrams. Okay, that is there in the topic. So light is one of the highest weighted chapters of your class 10th, and you will get maximum questions on ray diagrams. Okay, done. Now let's just summarize what we studied. For convex mirror, we have 2 cases, right? In the first case, on all the cases, although in 1 and 2 both cases, the image is virtual and erect, and it is always diminished. In case of convex mirror, the image is always diminished. Done, everyone? The image is always diminished. Okay, let's move on. This slide is very important for you. Sign convention of reflection by concave mirror. Now pay attention very carefully. This is the main slide for your diagrams, for your numericals. Okay, now this is clearly left hand side. This is right hand side. So the distances that are on left hand side, that is u, that is v, they will be taken as negative. Distances on the right hand side, u, v, object distance, image distance, they will be taken as positive. Height of object or image above principal axis will be positive. Below principal axis it will be negative. That is all that is there, you have to remember. Done? Okay, now again the same thing is written. Left side of the pole negative, right side of the pole positive. U, in case of concave mirror, u is always negative. We know that u is always negative. Now v, for real and inverted, the images were forming on the left hand side. So for real and inverted, the image distance is negative. For virtual and erect, the image was on this side. The image was on right hand side, right? So for right hand side, all the v will be positive. Done. Then focal length is negative. Focal length is negative. Why? Because concave mirror focus was on this side. So focal length of concave mirror is always negative. Done. Okay, see you later. Then radius of curvature is also negative because focal length is negative, and height above the principal axis is positive, height below the principal axis is negative. We all know this, very basic, but revise it again and again so that even your soul knows the answer. Done? Now, sign convention of reflection by convex mirror. Again, this is left hand side, right hand side. In here, the distances are negative. In here, the distances are positive. Height above the principal axis positive, height below the principal axis negative. Left hand side negative, right hand side positive. For convex mirror, U is always negative. One more thing, we know that for convex mirror, the nature of image is always virtual and erect. So for virtual and erect, we know the V will always be positive, and focal length of convex mirror is always positive, right? It is always positive. So radius of curvature is also positive. Height above the principal axis is positive, below the principal axis is negative. Done? Okay. Okay, let's move on to the next question, next thing. Before that, we are going to come live every day till 25th for science. After that, for SST, we'll also be coming live and we'll giving you strategies about Hindi as well. So make sure you subscribe this channel. Make sure you follow the WhatsApp channel. You will be getting links for PDFs, for all the things there. Okay? Okay. Let's move on to the, see, this is all the summary of what we have studied till now. What did we study? Concave mirror, we know focal length is negative. Convex mirror, focal length is positive. This is the slide you need. Okay? Concave mirror has two cases, real and inverted image, virtual and erect image. For real and inverted, all kinds of sizes of images can be formed. For virtual and erect, on the other hand, only diminished image will be formed. For real and inverted, U is negative, that is clear. V is also negative, and hence magnification is negative. Magnification, let me tell you in just a minute. Then virtual and erect, U negative, always V is positive. Virtual and erect, U negative, V positive for convex mirror. Done? Everyone understood? Hi imposter, how are you? How are your exams going? Done? Jai Shri Krishna. Okay, now magnification. What you have to remember about magnification? Magnification is the ratio of image distance by object distance, or magnification is the ratio of height of image by height of object. Oh, you are solo. Oh, you got blocked, right? I remember. Look, everyone, Hemant is there. Everyone was missing you so much. Okay. Now, for magnification, either you can write it's the ratio of image distance by object distance, or height of image divided by height of object. What it actually is, it tells us how much the size of image is changed, basically, or the nature of, what is the nature of image. Hi Adarsh, how are you? Done? Now magnification, let's just write the formula for mirror. For mirror magnification formula is what? Minus V by U, or height of image divided by height of object, right? Now, very important thing you have to remember. If your magnification is negative, that means the nature of image is real and inverted. It is real and inverted, right? If the magnification on the other hand is positive, if magnification is positive, the nature of image is virtual and erect. Done? Magnification of plane mirror is simply 1, because there is no magnification, right? Size of image and size of object both are same. Done? Clear, very good. Okay, let's move on to the next part. We have Now moving on to lenses, right? Moving on to lenses, we have two kinds of lenses, right? One is convex lens. In which of the lenses we have 6 cases? Let me know. In which of the lenses we have 6 cases? Convex lens or concave lens? Convex lens या concave lens. Now we have two types of lenses. Let's start with the very first, that is convex lens. Then let's start with convex lens. Again we have 6 cases, right? The first one, similar to the concave mirror. You know, similar to the concave mirror, at infinity the image will be at focus. Beyond 2f2 the image will be between f2 and 2f2. Let's just see it, okay? Now the very first case, object is at infinity, right? Object is at infinity. Where will the image be formed? The image will be formed at okay, when the object is at infinity, the image will be formed at focus. Very, very basic normal thing that we know, right? Whenever the object is at infinity, the image will be at focus. But in here, which focus? F1 or F2? In case of lenses, the focus we will be using is F2, right? For convex lens. Ma'am, 6 marks ka? Arey, how? What mistake did you do, Solo? Okay. Convex lens, Hemant is saying. What are you answering to, Hemant? Okay. So here the rays will be passing. See, at infinity the rays will be converging at focus. Convex lens is again a converging lens, right? It is a converging lens. Done. Now all the rays will be passing from the focus. All the rays will be passing from the focus, and this is something how you have to make your ray diagram. Done. What is the nature and size of this image? Now in case of convex lens, because we know it is similar to concave mirror. Done. At f, yes, very good, Hemant. So size is clear. Size is point sized. It is point sized, but nature of image in here will be real and inverted. That is similar to concave mirror. Similar to concave mirror. Done. Real and inverted. Very good, Abhinav. Great. Let's move on to the next part. The second case we have when the object is moving closer to the lens, that is beyond C. Clear? Great. Okay. Now object is beyond C, that is 2f1. Okay. The object is beyond 2f1, right? So what will happen again? Ray will be coming parallel to the lens, parallel to the axis, right? And it will be passing from focus. This is very clear, right? It will be passing from focus. Now one thing you have to take care of here, the another ray will be going from optical center without any refraction. Done? Without any refraction. So another ray going through the optical center without any refraction. Done? And see how you make it. If you make it with scale, right? So the diagrams will be as smooth. Ma'am, English mein come back. Great. That's very good. Finally, some paper that CBSE let you crack. Great. Okay. Hey. Hi. Hello. I don't know even how to pronounce your name. Okay, great. So the image formed will be this one. The image formed will be here, right? So again, the image is what? The image is between F2 and 2F2. Remember that you are writing F2 and 2F2 instead of 1, okay? Nature is real and inverted. We know that size is diminished. Correct? Everyone, anyone has any doubt till here? Diminished. Great, Abhinav. Hi, Durga. How are you? How are your exams going? I've seen you guys after so many days. I actually kind of forgot your names. Yes, Kalpana. Now I remember. Great. I remember you had a different name. I just forgot. Good. Okay, great, great. Okay, let's move on to the third case. We are doing ray diagrams today, so everyone pay attention. We are on the third case of a convex lens. The third case is the object is now at 2F1, right? Oh, solo. I did too. You guys. Done? Now, the object is at 2F1. What will happen? The first ray will go parallel. The first ray will be parallel and it will go and it will pass from F2. Done? It will pass from F2. Set 3, Himanshi. Oh, great. Okay, the another ray will now pass from the optical center. It will pass from the optical center and you can see they are clearly meeting below, just below the 2F2 mark, right? I think the size is a little bit bigger, but adjust that, okay? Done? So this is the image now will be again at 2F2. At 2F2, nature will be again real and inverted. Size is same as object. Same as object. Done? Make all your ray diagrams with a pencil, okay? That will only make you, let you correct all your mistakes, okay? Okay, let's move on to the next. We have fourth case, that is now object is between F1 and 2F1. Great. Okay, it is live destroyer. You guys are so smart. Okay, done. Beyond F3, Aman is saying F3. Where is F3, Aman? Done? Okay. Now the object is between 2F1 and F1. Great. So one ray will be coming parallel. One ray will be coming parallel. It will be passing from the focus. It will be passing from the focus. Right? Next, the other ray will be going parallel, will be passing from the optical center. It will be passing from the optical center and it will be meeting the other ray beyond 2F2. Done? Beyond 2F2. Yes, yes, Hemant, I do remember you. Okay, Hemant, do you remember these cases? So the image will be formed somewhere here, right? So the image is beyond 2F2. Size will be enlarged now. Size will be enlarged. Nature is real and inverted. Done? Oh, you guys are so worried about all the papers that are already done. grammar में marks कटेंगे, paragraph was long. The one that is coming, that is in front of you, it's like a big bear, huh? That is science, that you don't want to study. You want to discuss about the past. Okay, done. Hi ma'am, I am Rishit. Hi Rishit, how are you? Oh, you know science, great. You are worried about nothing. Ma'am, I have doubt in electricity. Yes, Kalpana, you can ask your doubt in electricity. Great. If you guys know science, na, CBSE will throw you a googly and then you'll come back and you're like, case, I'll do case on CBSE, CBSE is this, CBSE is that. Huh? Now you want to discuss about your previous exams. 25 ko. Himanshi is saying 25 ko? Yes, your science exam is on 25th. Great. This is clear. I don't want this, but I want you to be prepared, right? You have to study only chemistry. Okay. But go study other subjects as well. Okay? Either you are sitting in the exam hall, you know chemistry, and suddenly you go to physics and you're like, oops. We will need time machine for that, Abhinav. You can go back. There will be no these sessions, no live sessions. You will be studying in a candle light. Oh, physics is needed to study, ma'am. Now you want to study. Great. Study all subjects. I'm watching your live chats and you're like not here even worried about studying. Okay, let's move on to the next case we have when the object is now more near to the lens, that is the object is at focus, right? At f1, where will the image be formed? Who said? Hemant said, right? Or Himanshi said that I don't need to study science, I know science, I only need to study chemistry. Let me know, where will the image be formed? Okay, Kalpana. The image will be formed, in this case, the image will be formed at what? This is a classic case. If the object is at focus, the image will be formed at infinity, or the image is not formed at all. Done? So again, what you have to do, one ray will go parallel and it will pass from the focus. We haven't drawn any focus. This is f2 and this is to f1. Okay? So this will pass from focus, another ray, it will pass from optical center, something like this. A little bit of mishandling of the diagram happened. Wait. When you are making your focus be very clear, okay? Make sure the rays you are passing, they seems like they are parallel to each other. So what I did, I made the rays first. I made the rays parallel to each other first, and then I'll see, okay, this is passing from this, so this is f2, and somewhere here to f2. So I can clearly see that the rays are parallel. So image will be at focus. So this will be, yes, great, highly enlarged, and nature will be again real and inverted. Great. Yes, Abhinav, highly enlarged. What Gaurav? What did I forget? Okay, done. Let's move on to the next part, the last case of convex lens. The last case is when the object is between f1 and optical center. Now, where will the image be formed in this case? Where will the image be formed in this case? See, the image will be, well, let's see where the image is formed. So what will happen? One ray will come parallel and it will pass from the focus. Right? Now other ray goes from the optical center. But if you see, these rays are again like the sixth case of concave mirror. They are drifting apart, right? They are drifting apart. And if they are drifting apart, they can't meet, right? So what we do, we'll expand them or we'll extend them backwards. We'll extend them backwards, something like this. And we see that they are meeting somewhere here. They are meeting awfully close, somewhere here. And that will be my image, and in this case the image will be virtual and erect. Instead of, this is my image, image will be on the same side of lens. Image will be same side of lens, right? The size will be what? Enlarged. Again, size will be enlarged, and nature is virtual and erect. Nature will be virtual and erect. Understood, everyone? Hemant, Shanku, Himanshi, Nandini, everyone, understood? Any doubt? Sorry. Done? All the cases of convex lens is done, right? Now the next we move on to concave lens, right? So the first case again, just like convex mirror, just like convex mirror. Yes, Abhinav, I'll tell you the power of lens. Just wait for a few minutes. Okay? Sorry. Great, no doubt. Okay, so we move to concave lens. Now first case is at infinity. The object is at infinity, right? So when the object is at infinity, all the rays will be coming parallel. Just like this, all the rays will be coming parallel, and they are passing from focus. Now concave lens is what? Concave lens is converging or diverging. ABA. ABA? What is ABA, Hemant? Then all the rays will now be passing from focus. What kind of lens is my concave lens? Converging or diverging? Everyone, converging or diverging? So the image will be formed at F2, that is at focus at F2, right? Size is point sized, you can clearly see, point sized. Nature is virtual and erect. Nature is virtual and erect. Done? Diverging, diverse, very good. Shanku, Himanshi, great. The concave lens we have here is a diverging lens. This is a diverging lens. Done? Let's move on to the next case. We have the object is anywhere between optical center and infinity. Okay. Okay. Now, the object is between infinity and optical center, anywhere. Great. So, we kept it somewhere here. So, again, one ray will go parallel. One ray will go parallel, and we did a mistake here. All of you are really indulged in talking. Will this go? Yeah. Concave lens is a diverging lens, everyone. ऐसे ही ना, you will sit in the paper and you will leave out the silly mistakes that we do. This is a diverging lens. So what will happen? The rays will actually diverge out. They will actually diverge out, right? And they appear to be passing from focus. Which focus? The F1. the focus, which is f1. So they are coming back, they are coming back, they are coming back, they are coming back. That is why only the image is virtual and erect. So here the image is not at f2, the image is at f1. In case of concave lens, the image is at f1 because it is a diverging mirror. It cannot converge, it will diverge. It will appear that the image is forming at f1. Great. Virtual, erect and diminished. Concave is a diverging lens. Very good. Shanku, imposter, solo. Yes, Hemant, I corrected that. Very good. At least you acknowledge the mistake, found out the mistake. Okay, great. Let's move on to the next. Now, one ray will go parallel, right? And it will diverge. It will diverge, and if we expand it back, it will appear that it is passing from the focus, that is f1. Then the other ray, it will simply go from optical center. The other ray will simply pass from optical center, right? Without any refraction. So the image formed will be something like this here, right? So this is my object and this is my image. So image formed. Now object is anywhere between infinity and O. So image is between f1 and optical center. Nature of image is virtual and erect, right? And the size is diminished. Size is diminished. Done? Okay. Next, we are done with all the cases of ray diagrams in an hour, I'm guessing, right? Great. Now, sign convention for refraction here. There should be refraction by concave lens. Now, listen this very carefully. This is very important for your ray diagrams. Left hand side, this is right hand side, correct? So, all the distances in the left hand side will be negative. All the distances in the right hand side will be positive. Great. So, all the objects, height of object or image above the principal axis will be positive. Below the principal axis, it will be negative. Done. Anyone has any doubt till here? So, left hand side negative, right hand side positive. Done. So, U will be negative, V will be, in this case, in case of concave lens, V will be also negative because the image we form is virtual and erect, that was forming on same side of the lens. And focal length, anywhere the concave word comes, anywhere the concave word comes, you know the focal length is negative. Even for lens, even for mirror, focal length is always negative. So for concave lens, focal length is negative. Radius of curvature is also negative. Height above the principal axis, positive. Below the principal axis, negative. All these sign conventions are very important for your numericals, okay? Oh, everyone, clap for Hemant. Wrote a very, very good shairi for all of us. Done? Okay. Next, we have again refraction by convex lens. Similar. Left hand side, all the distances are negative. Right hand side, all the distances are positive. Done. And above the principal axis, the height is positive. Below the principal axis, the height is negative. Left hand side negative, right hand side positive. U is always negative. V, in case of real and inverted, in case of lenses, real and inverted, V will be positive. In case of lenses, for virtual and erect, V will be negative. Be very careful about this, okay? It is different for mirror and lenses. Focal length for convex lens, for convex mirror. Or for both of them, focal length is positive, radius of curvature is positive. Height above the principal axis is positive, below the principal axis is negative. Then, okay, what is left? Lenses, a very brief summary about lenses, a very small summary about lenses. We have two kinds, convex lens, concave lens. For first 5 cases of convex lens, all images are real and inverted, of all sizes, U is always negative, V is positive, magnification is negative because it is real and inverted images, right? Next, we have virtual and direct image. In the sixth case, U is always negative, but V is also negative in here, and magnification is positive. For concave lens, virtual and direct image is formed, U always negative, V also negative, and in this case diminished image is formed. In case of convex lens, enlarged image is formed. Okay, so magnification is positive. Done. Now talking about power of lens, see, this is my lens and rays are coming, right? It will converge them here. Or some other lens, rays are coming and it converges them here. So of course this is a farther away distance than this point. So the power of lens, the ability of a lens to converge, how far or how close it converges or diverges the rays, is called power of a lens. It is also inverse of focal length. Okay, I guess Abhinav asked this doubt, right? It is also inverse of focal length. So power inverse of focal length when focal length is in meters and it has a unit diopter. Done, everyone? Okay, and that is it for everyone. I have, again, let me mention a very important thing. There is a link in the description. All of you guys, whenever you want to study, go check that link. We all have combined all the diagrams of biology, important chemical reactions, as well as formulas of physics in one PDF. Okay, you can go check that out. It is like your cheat sheet. All the important stuff is everything there in that PDF. There is a link in the description. You have to put your mobile number, you'll get an OTP, and you can download that PDF for free. No cost for my kids. Okay? Everyone here like the session? Come on, like the session. In this whole live we covered all the ray diagrams, right? Their nature, the size of image they were forming, the position of image where was formed, and what else we covered? We covered everything, right? So make sure you like this session, subscribe the channel, join the WhatsApp channel as well. We will be covering all the these links here as well as the PDFs there as well. Okay? Okay, great. All the best for your exam. I will be coming live again on Monday. We will do the complete physics. It will be on Monday. Hemant, we will be doing complete physics, okay, from theory to all the important questions of all the chapters. Done. So till then, study chemistry. Study physics, okay? Whoever wanted to study chemistry, study chemistry. Till then, complete your physics and we'll do all the PYQs. Done? Okay. Bye, everyone.